Hello viewer, today I will explain you the color picture tube, how it functions and how it is manufactured. You have seen in case of the black and white picture tube, the electrons are emitted from the cathodes and after passing through the grid, screen, the focus and anode, they finally hit to the target. For discussion and for explanation, I have brought one color TV and its corresponding color picture tube. By looking, it seems that this is like the same as black and white picture tube. But if we see inside it, it is totally different. To demonstrate you, I will show you this is the tube, and if we take the cross section of this tube, it looks like as in case of this graphic. This is the cross section of a color picture tube. If we see inside it, it is not same as in case of the black and white tube. This is the gun portion, this is the phosphor screen, and in between the gun and the phosphor screen there is a shadow mask, which is the main source of generating the color. Now we will explain. Based on this gun as well as the screen, the tube may be of different type. Let us see once again on this graphic. Here in this graphic, the three gun can be arranged either in delta form or precision inline form. The corresponding screen may be RGB triads, and the shadow mask may be similar as that of the screen but less number of holes. The different tube may be single gun as in case of black and white tube. The triads may be horizontal of red, green and blue. In third type of tube, the single gun but three beams and passing through a grill and hit on the target which has the vertical shifts. Now we will take in detail the first where the guns are in delta form. This is called the shadow mask tube, and the details of the shadow mask tubes as are here. In case of shadow mask tube, the three guns all in delta form and originate three beams of blue color, green color and red color, and after passing from the shadow mask, they strike on their corresponding triads on the screen, and the separation between the screen and the shadow mask tube is 1 centimeter, and the number of triads or number of holes on the shadow mask are 4,40,000. It means number of dots are 4,40,000 into 3, because each dot contains 3 spots. The preparation of this shadow mask is not so simple. Since these are 4,40,000 holes on a small screen, say 20-inch TV or say 14-inch TV, to make these 4,40,000 holes in a screen is not a simple job. How we make these things? First we make a bigger chart and reduce through the negative. In the negative, where the holes are to make is black portion. Where holes are not required means this blank portion is white. We take a steel plate of 0.15 mm thickness and coat it with chemical coating for photographic purpose. We have explained how to make this shadow mask through photosynthesis method, and this was the single side edging. To edge double side, we put the negative and the photosynthesis on the opposite side, so that this shadow mask becomes tapered. The tapering is required to remove the diffraction. Diffraction may cause the defocusing problem in the picture tube. And now see in this figure, this is the electron beam falling on the shadow mask, and this is the shadow mask hole, and the corresponding beam, which is at present is green, it is striking on the green phosphor. The remaining is in shadow. This is the shadow portion and this is the shadow portion, and red and blue are in shadow. From figure it is well clear that the beam, electron beam, is much more thicker compared to the tapered hole. It means the efficiency of this shadow mask tube is much less. From black and white tube, we know that the minimum 300 microampere is anode current required. To take the 300 microampere current and see the efficiency of the shadow mask, which is hardly 20%, means we have to generate 1.5 milliampere anode current. It means it is not is same as in case of the black and white tube. Second thing, whatever the red, green and blue phosphors are available on the shadow mask as well as on the screen, they have their different efficiency. The red has the maximum electron beam efficiency, that is 42%, and in case of blue it is 28%, while the green has 30%. The beam passing through the shadow mask tube should strike on their respective triads, means the red beam should strike on the red triad, blue should strike on the blue triad, and the green on the green one. See here as in this figure, this is the red gun, and the beam coming from the red gun and passing through the shadow mask should only strike on the red phosphor dots. If these red phosphor dots are the beam, they are not coinciding, what will happen? We will not get the true red color, and that is the reason of impurity in the picture tube. How to correct that impurity? Means the red should strike on the red phosphor, green on the green and blue on the blue. To do this, we have to do the purity adjustment. In the purity adjustment, either to rotate the beam or shift the beam position, because we can't do anything inside the picture tube. So let us see here. To adjust this purity, we have put the purity magnets on the neck. If the color center of the purity magnet as well as the color centers of the three beam coincide, then we get the true color. If they are not coinciding, then we can force the beam to coincide either by rotating these magnets or rotating the deflection yoke. Beam is inside. How to correct it? Let us see the procedure. In this television, to find out the peyote magnets, in the neck, these peyote magnets are here. To rotate these peyote magnets, first lose this screw from here. So you can either rotate on both sides, one by one, or both at a time. To adjust the peyote, you take out this yoke slightly backside by doing the screwing this screw. The yoke will come forward, means the raster portion will be reduced, and in the reduced raster portion, see it whether red gun which we have given for the checking is purely red, and we get this red raster by switching off blue and green by their respective screen voltages. If red is not perfect red, rotate these magnets as per requirement so that the color center of the 3 beam and the color center of the deflection beam coincides. Once it is coincide, push back the yoke at their original position and tight the screw. In the similar way, tight this screw for these peyote magnets. Similar position can be repeated for the green and blue guns. The lot of magnetic field, which is either due to earth magnetic field or due to some twinge, may affect the 3 guns as well as the shadow mask. Since the gun is deviated or reflected by magnetic field, and these twinge and the earth magnetic field will magnetize the shadow mask, with the result you may not get the correct color on the skin. And how we adjust this thing? So that the red strike the red phosphorus, green strike the green phosphorus, and blue strike the blue phosphor. This is done by degauging, and degauging either manually or automatically. To do the degauging manually, we use degauger, and this degauger gives around 1000 ampere turn. And to do the degauging automatically, this TV receiver has the provision of this degauging coil. This degauging coil is made of copper, and it has around 400 turns. This degauging coil, which is here, can be explained with the help of graphic, and let us see in the graphic. The same degauging coil on the picture tube is here, and the separate degauging coil is here. To produce automatic degauging, we need minimum 500 ampere turn. It means the degauging coil, which has 400 turns and passing 1.25 ampere current, produce 500 ampere turn, and this much of the magnetic field is enough to reduce the any magnetization on the picture tube shadow mask. In initial stage, a very heavy magnetic field is required. As soon as the TV is switched on, when the TV is in operation, this magnetic field can be reduced to 0.3 ampere turn for the operation of the TV. Let us give some thought about the convergence problem of the shadow mask tube type TV receiver. Let us go to the graphic portion. And the convergence and the focus of this shadow mask tube having the delta gun operation of the beam is very difficult. Therefore, these tubes are no more produced in any part of the world. Some latest tubes have been produced and are manufactured at present, which are called precision inline tubes. And the construction and the working of the precision inline tube is almost same as in case of the shadow mask. Here in precision inline tube, the three guns are in same plane, and instead of making the shadow mask in the form of hole, it is made in the form of rectangle, and the corresponding the picture tube screen have the triodes in the form of rectangle. Means we have reduced the blank area in the screen as well as in the shadow mask tube. Therefore, the number of electron passing through the hole is more. But we have the disadvantage that making the three gun inline, the gun size is reduced and it gives around 30% less brightness compared to the delta gun shadow mask tube. To have the compromise between the brightness and the convergence as well as the focus problem, now this is the latest method of the tube which are produced and put at present in the color TV receiver. To demonstrate you, we have brought here one color TV and its picture tube which are used at present in all these color TV receivers. And let us see what is inside in this gun. This is the gun assembly of a precision inline picture tube which has the separate three guns. Here the first gun is red, the second is green, and the third is blue one. Each gun has its own separate heater and the grid assembly. In case of Lawrence tube, there is only one gun as in case of the black and white tube, but only the phosphor coating and the shadow mask arrangement is different compared to black and white picture tube. In the Lawrence or chromaton tube, the phosphorus dots are in the form of horizontal strips. Each horizontal triad is a form of red, green and blue. To scan the red, green and blue, a sine wave can scan simultaneously red, green and blue. If there is no sine wave, means the continuous scanning in case of the black and white tube, then the beam strikes on the green phosphor. How to modulate this sine wave for the formation of the color is done in a complicated way. The sine wave, which is same as the subcarrier frequency, is modulated over 4.5 kilovolt signal, and this 4.5 kilovolt signal is given to red and the blue grids, and the red and blue grids, they are internally connected from the red and the blue phosphor. The problem may be either the amplitude of beam is more or it is less. If the amplitude of the beam is more, it may cross the red beam, red phosphor, and may reach to the another green, resulting in a purity problem. If the amplitude of this sine wave is less, it may not touch either red or the blue, means you may get less chrominance signal. The formation of this tube, to arrange the number of triodes are same as the number of lines in a TV receiver, and in the PAL system the active number of lines are 588 lines. It means to generate 588 triodes, and each triode is connected with blue and red wire, means we need 588 into 2 wire, which is not so easy to do the wiring in a picture tube. Therefore, this type of Lorentz tube could not come as a production model for the public, but was developed in the laboratories. And this is about the Lorentz tube, where convergence and focus has no problem, but the problem was only in the color, either for purity or for hue. So therefore, this tube could not get success in the commercial market. The third tube, which is most advanced and overcome the problem of luminance, chrominance, purity and convergence, is called Trinitron tube, which had the additional advantage compared to other tubes. The cross-sectional view of a Trinitron tube is here. In this tube, it has the single gun, and single gun produces 3 different beams, and in place of the shadow mask, it has the grills, which has the vertical strip, and in place of triodes, it has vertical strip in form of the red, green and blue. The construction of the Trinitron tube is much more precision compared to precision in line tube or the shadow mask tube. Let us see the working principle of this Trinitron tube. Here in Trinitron tube, this is the gun, and it is producing 3 different red, green and blue beams, and has the single large focusing arrangement, which is of the type of a optical lens. And as we know, the beam can be deviated by changing the potential difference. The beam passes through different 3 cross sections, which are separated by 4 plates. The inner 2 plates, they are at a common potential, while the 2 outside plates have the different voltage. When the green beam passes through the internal plates, there is no deflection, because there is no potential difference. To move the either red or the blue beam, we create the potential difference between one inner and outer plate, and it is very easy to generate this potential difference through a resistance. Therefore, beam can move upward and inward, means make the easy focus as well as the convergence. Therefore, to adjust the convergence, there is no need of any coil or magnet to do the convergence, as is required in case of the delta gun type or precision inline tube. With this result, we get double the brightness compared to precision inline tube, and the width of gun is almost half to have the same electron efficiency. Therefore, making a thin gun, one can produce very small picture tube through Trinitron technology, which is not possible through delta gun type of picture tubes. Therefore, Sony Corporation of Japan has developed its own patent, and nobody can copy this latest technology. So, you have seen three types of picture tubes: the delta gun type shadow mask, or precision inline type shadow mask tube. The second one is the chromaton or the Lawrence tube, and the third and the final and the latest technology is the Trinitron tube. I hope you might have understood the working principle of a color picture tube. Thank you.